Hello everyone. Today I am going to share you again another video, and it's part of the C programming made AC tutorials, and I will be showing to you a particular problem, programming problem, and we'll be solving this one. Right, and I'll try to discuss the program line by line. In a way, along the way, I'll be sharing to you guys the behavior of the program. Okay, so that's it, and I hope that the end of this video, I'll be able to share with you the techniques and the ways on how to analyze programming problem, and I'll be able to discuss also the logic and the algorithm of the program solutions. All right. Okay. So I would like to show you my online notepad. Right. uh, this is what I'm going to discuss today in this particular video, but I would like to suggest that please help my YouTube channel. Please click subscribe, and please share this channel to your friends, relatives, especially those who are wanting to learn C programming language, or those who are eager to know how to do programming. Because as I always said that if we want to be good in programming, the good start is on learning C programming language. Okay, so I am going to discuss this problem. Right, design a program to ask for a range of values. Now here, when you say range of values, we'll be asking for two values, and the first value for me, right, ideally must be smaller than the second value. For example, our program will ask for the first value, say for example 1, and then eventually it will ask for the second value, say for example 9, and then that 1 to 9 can be considered as a range of values, right? And if assuming the user entered 10, then the second value is 1, that's 10 to 1. I'd love to display an invalid range, right? That's my personal interpretation. And then our program will tend to evaluate and display all prime numbers. All right, now I would like to make it clear what is prime numbers. What is prime, right? um, on my own understanding, prime numbers are actually numbers who are only divisible by itself, right? For example, 9. uh, can we factor 9 by any numbers other than itself? 1 times 9 is 9. How about the other uh, factors? 3 times 3 is 9. So therefore 9 is not a prime number, right? So a prime number, in my own understanding, is any numbers which factor is uh, uh, any numbers which are actually divisible by itself only. Any numbers which is greater than 1, of course, greater than 1. So it should start from 2 up to infinity, right? That's prime numbers. So for example, 15 times 1 is 15. How about the other mathematical expression that will end up 15? 5 times 3 is 15. So therefore, 15 is not a prime number. All right. 7. 7 times 1 is 7. Do we have another factorial expression that will result to 7? Nothing. So therefore, 7 is a prime number. All right. But then mostly odd numbers are actually prime, mostly. But there are some odd numbers which are not prime. 9, for example, is not a prime number because 9 can be divided by 3. All right. 15 also is not a prime number because 15 is divisible by 5 and 3. So a prime number can only be divided by itself. That's prime numbers. Okay, so our program will ask for two values as a range, and then out from that, for example, the value is from 1 to 10, the range is from 1 to 10. Within those 1 to 10, our program will try to digest, evaluate, and filter and display all prime numbers within the bound of 1 to 10. All right, so here I have here a program, okay, which I'm going to explain to you line by line. Sounds technical, but then you have to take it, you have to digest it, right? If you want to be good in programming, because the foundation of programming for me must be C programming language. Okay, so here, um, I declared num1 and num2 as an integer variables. This is actually I intend to use this for my range, right? First value and second value. Then this flag variable or flag underscore var, I will be using this one as actually a variable to determine whether a particular value is prime or not. Okay? And the value of this flag var must be either from 1 or 0. Then I variable, which is also an integer, same with G, I'll be using these variables for my loop statement. Because along the way, we'll be using nested loop just to determine whether this particular value is prime or not. Okay? So here, um, I did use one printf and two scanf. This will ask for two numbers. Enter two range, input integer numbers only. So I will be needing integer values. And the first value will be stored at num1, then the second value will be stored at num2. Now here's the thing. The program will display prime numbers from the range, right? Data placeholder and data placeholder. That refers to num1 and num2. Then followed by this condition. What is this condition? This is what I said a while ago. That for me, in my own understanding, in this particular problem, if the range or if num1 is greater than num2, then that's an invalid range. The range must be from smaller value to a larger value. 2 to 10, 3 to 15, right? 1 to 5. Not in any way around. For example, 5 to 1, that's an invalid range. 10 to 7, that's an invalid range for me, right? Okay. So the purpose of this conditional statements in here is just to determine whether the given range is an invalid range or not. Okay. Now here's the thing. I have here for loop statement, all right? And then within my for loop statement, I did use another loop, okay? And the purpose of this one, which I'm going to discuss in detail in a while, the purpose of these lines will check if the given value is a prime or not prime. Now, we will try to discuss this one line by line, all right? So, assuming our num1 is 1, for example, and our num2 is let's say, for example, 5, all right? So question is, what is num1, which is 1, greater than num2, which is 5. The condition is false. So if the condition is false, do not display or do not perform this one and proceed to the next. Okay? So it is a for loop statement. For I is equal to num1 plus 1. And if the condition is true, even if I is lesser than num2, then perform. Okay? So here, our I is how much? Num1 plus 1. Our num1 is 1, right? It's in here based on this example. So our num1 is 1 plus 1, that is equal to 2. Okay? And then is your I greater than num2? In short, is our I, which is 2, right? Not greater than, less than num2. How much is our num2? Our num2 is 5, right? So is our I lesser than 5? The condition is true, right? Now, since this condition is true, okay, since this condition is true, we have to perform the loop body. Now, the loop body says flag bar is equal to 0. So I'm trying to initialize flag bar by 0. Okay. Next, another for loop. Alright, for j is equal to 2, and if this condition is true, perform the loop body. The condition says, is your j lesser than or equal to I divided by 2? So at first we are trying to initialize g by 2, alright, and then we tend to ask if our g is lesser than or equal to our I divided by 2. Good as saying that since our g is 2 less than or equal to what? Our I. How much is our I? Our I is in here, 2. Right? I 2 divided by 2. So is our 2 less than or equal to 2 divided by 2? And that is 1. So is 2 less than or equal to 1? This condition is oh, not 1. Here. Meaning this condition is false, right? Now since the condition is false, what's next? Get out of this loop and exit. Proceed to the next line of instructions. The next line of instruction says, is flag bar equal to 0? Right? So is our flag bar, okay, please follow my screen, is our flag bar contains or equal to 0? How much is our flag bar? Our flag bar is 0. So meaning the condition is true. Now, if this condition is true, what's next? Right? What's next? Display whatever is the value of I. So it displays the value of our I. So how much is our I? Our I is 2. Right? So display 2. Are you following? Right? So after displaying 2, what's next? Curly bracket. What is this curly bracket? It is actually a curly bracket of the mother for loop. So meaning it goes back. And because of this plus plus I, our I becomes how much? Our I becomes, previously it was 2. And now, because of that plus plus I, it becomes 3. Right? So, since I is 3, the question is, how is this condition? Oh no, I'm sorry. This one. Is the condition true or false? Meaning, is I less than num2? Our I is 3 and our num2 is how much? Our num2 is 5, right? This one. Our num2 is 5. So meaning the condition is true. If the condition is true, what's next? Initialize again. Flag var is equal to 0. Are you following? Huh? The logic of this program is very technical, but for as long as you're trying to expose yourselves to programming problems and programs, you will get used into it, and eventually you'll tend to understand the logic easily. Trust me, I was there. When I was in college, um, I find it struggling but interesting, right? So we are now initializing flag var by 0, and here another for loop statement, right? G is equal to 2, and the condition says, is your G less than or equal to our I? Now our I this time is how much? Our I is 3, right? Divided by 2. 3 divided by 2 is 1. 1 point something, but try to ignore the point something because our variables are all declared as integer variables. So we are only storing integral value. Okay. So is our G is how much? Our G is 2, right? Is 2 less than or equal to 3 divided by 2, which is 1. The condition is right. Am I right? Okay. So the condition is what? The condition is false. Are you following? Right? Now, since the condition is false, what's next? Since this condition is false, what's next? It goes in here. Do not perform this one and exit. Try to check. Is flag bar, right? Is flag bar equal to 0? Our flag bar is how much? Our flag bar is 0. So meaning the condition is true. If the condition is true, what's next? Display the value of I. So we'll display what? We'll display how much is the value of I. Our I is 3, right? So display 3. Are you following? So next, what's next? After displaying the value of 3, here comes a curly bracket, and that curly bracket is actually the partner of this one. So this time I now becomes how much? I now is 4, right? And is I less than num2? Our I is 4 and our num2 is 5, meaning the condition is true. Now since true, perform the loop body. The loop body says initialize flag bar by 0. Next, for loop again. Okay, for loop. So we are initializing G by 2, and then we tend to check if G is less than or equal to whatever is the value of I. Our I is 4 divided by 2, meaning is your J, which is 2, less than or equal to 4 divided by 2? That's 2. Is 2 less than or equal to 2? The condition is true, right? So if the condition is true, perform this loop. So what is then the content of that loop? The content of that loop is I modulo j. Take note, the function of modulo operator is to get rid of the remainder and stored it to a particular variable, right? So is I modulo j equal to 0, meaning is our 4 modulo j, our j is 2, meaning is the remainder of 4 divided by 2 equal to 0. Yes, because 4 divided by 2 is 2 and the remainder is 0. Now since the condition is true, what's next? Perform this one. So meaning perform what? Perform flag bar. Okay, flag bar is equal to 1, and then what's next? Break. Break means get out of the loop. This is the loop body. Get out. When it gets out, it goes in here. All right. So it says is flag bar equal to 0. Okay. No, our flag bar is 1. It is not equal to 0. So meaning do not perform this. Right? So next, I now is how much? I now becomes 5. Because after not printing in here, it goes this curly bracket and it goes back to the mother for loop. This one. Okay, this one. So I now becomes 5, right? And the condition says is your I less than num2. Our I is 5. Is it less than the value num2, which is 5? The condition now becomes false. If the condition is false, what's next? Return 0, meaning exit from your program. Right? So our program stopped. What is the screen output? The screen output is 2 and 3. Meaning from the range of 1 to 5, there are only 2 prime numbers, and that is 2 and 3. Okay? Are you following? Right? So we'll try running this program. It's in here. I actually copied and pasted that program, this one. Okay? And we'll try clicking run button, and we will supply the same value. Let's see if it is correct. It was 1 and 5, right? Our num1 is because this num1 will be stored to this one value will be stored to num1, and this 5 will be stored to num2. We'll try to first. See, the prime numbers are 2 and 3, which is actually similar to this one, 2 and 3. All right. So prime numbers from 1 to 5 are 2 and 3. We'll try another value. We'll try to do some reverse. Say for example, our num1 is 5 and our num2 is 1. The program will display prime numbers from 5 to 1 are nothing. It displays invalid range. Why? Because in my own understanding, and in this particular problem, 5 to 1 range is an invalid entry. Meaning if your num1 is greater than your num2, then that's an invalid entry. That's my personal understanding of the problem. Right? Now we will try having another value. All right? Now say for example, if what if our num1 is 7 and our num2 is 10. Yeah, 6 for example, and our num2 is 10, meaning the range is from 6 to 10. Right? So we will try uh, solving this problem. Okay. What if the range is from 6 to 7, 6 to 10? What are the prime numbers, right? We'll try doing some manual simulations. Okay. So on the first condition, is your num1 greater than num2? The condition is false. Why? Because our num1 is how much? 6, and it's not greater than 10. So since the condition is false, do not print invalid range. Move to the next line. So the next line says what? It's for loop, right? I is equal to num1 plus 1. So our I becomes how much? Our num1 is 6, right? Plus 1, that is how much? 7. Okay? Our I is 7. Condition. Because we are using for loop. The condition says is I less than num2. Meaning is our I, which is 7, lesser than 10. The condition is what? True. Now since the condition is true, we have to perform this loop body. The loop body says what? Flag bar equal to 0. Meaning you initialize flag bar by 0. Next, another for loop. J is equal to 2, right? And then is our J, which is 2, alright, less than or equal to our I. Our I is how much? 7 divided by what? 2. Okay? Divided by 2. I'm sorry. Here, divided by 2. So 7 divided by 2 is 3 point something. And since we are dealing with integer variable, so that's 3. So we tend to ignore the remainder. So is 2 lesser than 3? It's true. Now, since the condition is true, perform this one. Right? So, if condition, sorry, right? If is what? Is your I modulo G equal to 0? Meaning is our I, which is 7, modulo G, which is how much? 2, right? Equal to 0. The condition is false. Because the function of modulo is to get rid of the remainder. 7 divided by 2 is 3.5. And that 5 is the value for modulo. And that is not equal to 0. So meaning the condition is false. If the condition is false, ignore, do not perform, proceed to the next. So the next line is what? That one. So what is that? Is flag bar equal to 0? How much is our flag bar? Our flag bar here is 0. So meaning the condition is true. If the condition is true, what's next? Display whatever is the value of I. Our I is how much? Our I is 7. So display 7. Right? Display 7. Now here, after displaying 7, it goes to this curly bracket. And because of this curly bracket, our program will get back and increase the value of I because of this plus plus I. So our I now becomes how much? From 7, it becomes 8. Alright? So 8. condition is your I, okay, is your I, which is 8, lesser than your num2, which is 10. The condition is true. Now, since the condition is true, what's next? Initialize flag bar by 0. Okay, flag bar by 0. What's next? Okay, are you following? This is too technical, but you have to do it. You have to understand this program. Okay, now, since the condition is true, get inside, right? Right? So we are now initializing flag bar by 0. And then the next one is another loop. So initialize g by 2. Next is what? Check the condition. If your g, which is 2, less than or equal to what? I divided by 2. How much is our I? Our I is what? 8. Alright? So 8 divided by 2. How much is that? 8 divided by 2 is 4. Now, is 2 lesser than 4? True. Now, if the condition is true, what's next? Perform these lines. Okay? And it says what? And it says is your I modulo g equal to 0. Good as saying is 8 modulo what? J. How much are J? 2 equal to 0. 8 divided by 2 is 4 and the remainder is 0. The function of modulo is to get the remainder. So meaning the remainder of 8 divided by 2 is 0 and it's equal to 0, so the condition is true. Now since the condition is true, what's next? Initialize flag bar by 1. Flag bar is equal to 1. And then break. Break means get out from this loop and it goes in here. Right? What is the condition? Is flag bar equal to 0. Our flag bar is 1, meaning the condition is false. Now since the condition is false, goes in here and get back. So when it goes back, how much is I? Our I now becomes 9 because of plus plus I. Are you following? Okay. Now here is your num1. So we are here. Okay. So is your I, which is 9, less than num2. Our num2 is 10. Okay? The condition is true. If the condition is true, perform the loop body. Right? So perform what? Flag bar equal to 0. What's next? For loop. Here. Please follow my mouse pointer. For loop. J is equal to 2. Alright? And then is your J less than or equal to I? Our I is 9 divided by 2. Right? Good as saying is your J, which is 2, less than or equal to 9 divided by 2. 9 divided by 2 is 4.5. Get rid of 4 because we are dealing with integer variables. So 2 is lesser than 4. So that's true. The condition is true. Now, since the condition is true, right, perform this loop body. Okay? So the loop body says is I modulo G equal to 0. Good as saying is your I, which is 9, divided by J, which is how much? 2, equal to 0. Meaning is the remainder of I divided by 2 equal to 0. The remainder of I, the remainder of 9 divided by 2 is 5, right? 5, and it's not equal to 0. So meaning the condition is false. Now, knowing that the condition that this condition is false, do not perform this body and move to the next line. The next line says what? Is flag var equal to 0. How much is our flag bar? Our flag bar is 0, meaning this condition is true. Now, since this condition is true, what's next? Perform this one, meaning display the value of I. So, how much is our I? By the way, I'm sorry, there's something wrong with this. Okay, so here, let's try to go back to here. We initialize G by, I'm sorry, we initialize G by 2, right? And we check the condition. Is your J less than or equal to I divided by 2, meaning 9 divided by 2. 9 divided by 2 is 4 point something, meaning 2 is, since 2 is lesser than 4, the condition is true. So since this condition is true, perform this loop, right? And the loop says what? Is your I modulo J equal to 0? Our I is 9, right? Modulo J, which is 2. Is it 0 or not? Okay, it's not, right? Because 9 divided by 2 is 4 point something, 4.5, and 5 is the remainder, so it's not equal to 0. So that is what? False. Now, since the condition is false, what's next? Because of this curly bracket, it goes back in here, right? Then the owner of this curly bracket is this one. So meaning loop again. So when it loops again, our G now is how much? Our G now becomes 3. Because previously it was how much? It was 2. Right? Our G was 2. And when it goes back, it becomes 3. And here, 3. Alright? So is 3 less than or equal to your I, which is 9 divided by 2. 9 divided by 2 is 4 point something, and is 3 less than or equal to 4. The condition is true. Alright? Now, since this condition is true, get inside the loop. The loop says what? Okay? So technical. The loop says is I modulo G equal to 0. Good as saying, is your I, which is 9, modulo J, right? How much is our J this time? Our G is 3. Okay? So is I modulo 3 equal to 0. 9 divided by 3 is 3. Meaning the remainder is 0. So this condition is true. Right? Now since this condition is true, are you following? Perform. Initialize flag bar by 1. And what's next? Break, meaning exit from this loop. And when it exits, it goes back in here. The condition says is flag bar equal to 0. Our flag bar is how much? 1. That makes this condition false. Right? Now since this condition is false, do not perform this one. Move down. When it moves down, it goes back again in here. And when it goes back, how much is our I? Our I now becomes 10. Question or condition, is 10 lesser than 10? Not. It's false. Now, since the condition is false, all right, here we have to exit from the loop and jump up in here. Return 0 means stop the program. Exit. And it stops. So meaning, if we are to check for the prime numbers of 6 to 10, there's only one, and that is 7. Right? So we'll try to check if our simulation is correct. Our manual simulation is correct. Right? So 6 to 10. Prime numbers from 6 to 10 is 7. Okay? Meaning our simulation of the program is entirely correct, and the program is correct. Now we'll try giving some examples. For example, we'll say let's say 1 to 10. From range of 1 to 10, how many prime numbers? There are 4: 2, 3, 5, and 6. Okay. So from 1 to 20, how many prime numbers? Prime numbers from 1 to 20 are 2, 3, 5, 7, 11, 13, 17, 19. Meaning these numbers are only divisible by itself. There's no other factors, right? You cannot say anything other than saying 3 times 1 is 3, 5 times 1 is 5, 7 times 1 is 7. I mean, they're only divisible by 1. Okay? So, I hope I hope I was able to explain the program. Yes, I know I was able to explain the program. The problem is, how is your understanding? Is the algorithm, the logic of the program okay or not? Now, this is my suggestion. Try to expose yourselves to programming problems, right? There's so many programming problems in the internet, and you watch this video, you review this video from time to time, and eventually you will understand the logic. At first, it's hard. I know. I was there. Okay, but when you are going to do it regularly, and when you tend to enjoy getting tired of yourself, getting tired of understanding the flow, the logic, then you're on the right path. Congratulations. Okay, if you had headache after analyzing the problem, congrats, you're on track. Okay, so thank you so much for watching this video. I hope I was able to give you a good explanation on this program. God bless you. God bless us all.